Hey everyone, let's go ahead and get started by taking a look at Unit 1, Lesson 1, Harnessing Human Energy. So whenever you see the stop sign here, that's going to be a sign that you need to go ahead and stop and write something down in your notes, which you should have your notes in front of you. Press pause in the video whenever you need to in order to write something down. Let's start by looking at our essential question, which is how is it possible to charge electrical devices when the power is out? And your challenge in this unit is going to be to design a way for rescue workers to get their energy to their electrical devices, even when they're on rescue missions far from electrical outlets. And we'll go through that in just a moment. To do this, you're going to have to learn about energy, including the energy that's stored in our bodies from the rescue workers, and figure out a way to capture that human energy. So scientists and engineers have been inventing new ways to solve everyday energy problems, and now it is your turn. So Chapter 1, what is energy? This is the overview. Again, it introduces the fact that you will be a student in energy scientist and learn what energy is and how you're going to know whether an object has energy. And you're going to answer some questions as we go along. So again, the stop sign indicates that you'll be filling some things in on your notes. But physical science, this is what we're starting with here, and it's a study of the physical world. And it's not just what you can read about in books, it's also the process used to figure out that knowledge. So you're not just going to learn about it, you're actually, you're going to act as physical scientists. And physical scientists study physical systems and processes to learn about what makes things work the way they do. Energy is one of the things that physical scientists investigate. So in this unit, you're going to have the chance to deeply explore a few ideas about energy, and you're going to build on these ideas throughout the year. So let's go ahead and stop here and write down our Chapter 1 question, which is what is energy and why does it matter to the rescue team? At this slide, what I'd like you to do is go ahead and think in that box, go ahead and draw or write down what's the first thing you think about when you hear the word energy. And then in the next two columns, you'll have a column that says things that have energy and things that don't have energy. I want you to take a look at these 14 different pictures, and I want you just to pick 5 that you would put in the column under things that have energy, and then 5 under the column of things that don't have energy. Obviously, you'll have some extras, and that's okay. Let's go ahead now and take a look at our challenge for this unit.
Come on, let's check the next floor.
Abby, how stable is this building?
After the earthquake, not sure, but we don't have much time to evacuate any survivors.
Abby, I think I see someone. Are you okay? Can you hear me?
She's breathing and she has a steady pulse, but she needs to get to the hospital. Call in our position.
My battery's dead.
Wonderful. Use mine.
Your battery's drained too.
You can get up now, Anna.
Good thing it's just a test drill, right?
Well, it could be worse. Guess we still have working flashlights. Oh.
Guys, we have to find a way to keep these batteries charged.
Hey, you must be the rescue workers. Welcome to the Energy Research Lab.
Thanks.
So, I hear your batteries died during a drill.
Yeah,
If it would have been a real emergency, we would have been in trouble.
serious trouble. We rely on the radios to communicate with emergency workers like police, fire departments, hospitals.
And we don't know how long we're going to be in an emergency situation. We could be out there for a while.
It's not feasible to plug your devices in to charge while you're on a rescue mission.
No, we can't count on it. We could be out in the wilderness or the power grid may not be working. Even if it is on, we may not be in one place long enough to charge it.
Okay. So, what you really need is a portable energy source that can power a small device.
But not just radios. We have GPS and flashlights.
Got it. We'll put the team to work and be in touch when we have a few designs.
Sounds good.
Thanks.
Okay, so I want you to stop and think what your initial reactions were to the video and what questions do you have about that video, and write those down. So overall, we have a unit question, which is how is it possible to charge electrical devices when the power is out? And then we narrow that down a little bit to the chapter 1 question, which is what is energy and why does it matter to the rescue team? So today's question is what is energy? You're going to be dealing with simulations from our Amplify textbook and we're going to use that simulation in order to make a light shine. So the first thing we're going to do is take a look at a preview of how to use the simulation.
This is the Harnessing Human Energy simulation. It lets you build systems using different energy sources and devices. Let's build a system using the crank. To start, you will go to the Select Energy Source box. In the box, you'll see 4 different sources of energy: sun, crank, fuel, and wind. You can set the amount of energy here for some of the sources. Let's select the crank as our energy source. Next, you'll add devices by dragging them into this box. Let's add the flywheel, the ball launcher, and the spring. Notice that the flywheel and ball launcher fit together. This tells you it's a working connection. Devices that don't fit together won't work together. Let's test our system by pressing Run in the top left corner. To use the crank as an energy source, you need to turn it. Drag the handle in the direction the blue arrow points. As the crank turns, the number above it increases. This number represents the amount of energy being transferred into the system. Sometimes you will need to press transfer to make your system work. It works!
Okay, great. So now I want you to go ahead and stop and answer the 2 questions there. What can you do in the sim and what did you observe? Then for part 2 here, you're going to actually go into the simulation yourself and determine a way to make a light shine. So you can go into the Harnessing Human Energy simulation by typing in this URL, or you can go through your Amplify textbook and you're going to build a system that makes a light shine. After you build that system, you're going to record your thinking. So go ahead now, go over to the simulation, build a system that makes light shine, and then answer the question based on your ideas about energy. Where do you see examples of energy in the system that you built? Last but not least, you are given a term system, which means a set of interacting parts forming a complex whole. With that, you are to go ahead and fill in the 4-part flashcard where you are going to put the definition from class here and then 2 related words and a symbol or a picture that's hand-drawn, and then you use the term in a sentence so you show that you understand what it is. The last 2 questions of this lesson that I'd like you to reflect upon are, how is the term system related to the simulation that made a light shine? And what are some ideas about whether any of these systems you built in the sim might work for the rescue team? And that's it.